In July of 1942, a Messerschmitt took off from Leipheim Airfield in Bavaria, but it was no ordinary aircraft. It was the Me-262, the world's first operational jet fighter. Fueled by twin Junker Jumo 004 engines, it soared 120 miles an hour faster than the P-51 Mustang. On paper, this marvel of German engineering could outrun and outgun any Allied fighter. Yet the Me-262 failed to secure Germany's salvation. How did a jet fighter so advanced, so potentially devastating to Allied air power, ultimately fail to change the course of war? And how did it spark a new era in aviation? Now, in the years leading up to the Second World War, the German aviation industry stood at the forefront of technological innovation. Germany's engineers and strategists recognized that the standard boundaries of piston-engine aircraft were rapidly approaching their ceiling. Speeds above 400 miles an hour were challenging for conventional propellers and superchargers to achieve efficiently. The race was on to discover entirely new propulsion methods that could break free from the traditional constraints of airflow around propeller blades. The idea of a jet engine had circulated among forward-thinking engineers since before the war. In Britain, Frank Whittle experimented with gas turbines, while in Germany, scientists at Heinkel and Junkers pursued similar concepts. The Messerschmitt team, too, had its vision to create an interceptor that could dominate the skies, climb faster, run swifter, and strike harder than anything the enemy could bring forth. As the Luftwaffe expanded in the late 1930s, the possibility of fielding a jet-powered fighter became more than a distant dream. High-level planners imagined swarms of sleek jets tearing through Allied bomber formations. These jets would catch enemy aircraft utterly off guard with their unimaginable speed. It was a vision that promised not just parity with the Allies, but a leap ahead, one that could re-establish German superiority in the air. The early efforts had their share of skeptics. Some doubted the feasibility of turbines spinning at tens of thousands of revolutions per minute. Others questioned if the fuels required would be too scarce or too complex, but the Messerschmitt Design Bureau pressed on. By the time war was fully underway, the Me-262 started to emerge from the drawing boards. The dream was no longer just a theoretical exercise, it was becoming a tangible war machine. The Messerschmitt Me-262 represented an evolutionary shift. Instead of relying on bulky piston engines slung in the nose or wings, its designers placed two streamlined nacelles under swept wings, each holding a Jumo 004 turbojet. This allowed for a sleek fuselage that minimized aerodynamic drag. This aircraft's form was elegant and predatory, with a pointed nose and an almost shark-like profile. This was no adaptation of a pre-existing airframe. It was engineered from scratch to take advantage of jet propulsion. Structurally, the Me-262 was mostly built from aluminum alloys that were common at the time. In its earliest prototypes, designers experimented heavily with aerodynamic features: slightly swept wings to reduce compressibility issues at high speeds, tricycle landing gear to provide better ground handling, and pilot visibility on takeoff and landing. The latter was a notable departure from tail dagger configurations that were common in that era. The result was a fighter that looked decades more modern than its contemporaries. Another hallmark of the Me-262 was the cockpit design, which was relatively advanced for the time. Although still somewhat cramped, it provided good visibility forward. The canopy framing was minimal to enhance situational awareness. This was crucial because the kind of speeds that the Me-262 could reach demanded rapid decision-making and careful navigation. The pilot sat ahead of the wing with the nose-mounted guns right beneath the instrument panel, allowing for a direct line of sight to targets when making head-on attacks. Every inch of the aircraft was carefully considered. Engineers needed to ensure that the new engines would not simply overwhelm the airframe with thrust it couldn't handle. The weight distribution was key. The heavy turbojets, placed close to the fuselage, preserved a balanced center of gravity. Special high-strength materials had to be used in the engine mounts and forward fuselage areas to handle the vibration and torque produced by the early jets. Although the Me-262's overall construction was conventional metalwork, the way these elements were put together represented a new direction in aviation design thinking, one that would echo through subsequent decades. At the heart of the Me-262's potential was the Junkers Jumo 004 engine. Now, this turbojet was among the first of its kind to go into series production anywhere in the world. Its basic design, a compressor, combustion chambers, turbine, and exhaust nozzle, became the blueprint for all subsequent jets. But as pioneering as it was, the Jumo 004 suffered from numerous teething problems that limited the Me-262's combat effectiveness. Each Jumo 004 produced around 1,980 pounds of thrust, giving the Me-262 a top speed approaching 540 miles an hour at altitude. However, the engine's reliability was notoriously poor. Constructed in a Germany increasingly starved of strategic materials, the turbines had to use steel alloys that were inferior to what optimal designs required. The turbines wore out quickly. Engines often had service lives of as little as 25 flight hours before major overhauls were needed. Starting and managing these early jets required careful attention. The pilot had to be gentle with the throttle to avoid compressor stalls. Rapid throttle movements could flame out the engine or cause a damaging surge. Maintenance crews were constantly busy replacing worn turbine blades and combustor liners. Each time an Me-262 took to the sky, it was a bit of a gamble. Would both engines function properly at crucial moments? Still, considering the jet propulsion was essentially being invented on the go, the Jumbo 004 was an extraordinary step forward. It proved that turbojets could power a high-performance fighter, and it gave the Germans a glimpse of the future. The lessons learned from its vulnerabilities would become invaluable to post-war designs worldwide. The Me-262's firepower was nothing short of formidable. Its standard fighter version, the Me-262A1A, carried four 30mm Mk108 cannons in the nose. These cannons could shred Allied bombers with just a few well-placed bursts. The Mk108's high explosive shells were particularly devastating. A handful of hits could break a bomber's wing spar or detonate its bomb load. Against the lightly built fuselages of Allied fighters, a short burst was often more than enough to claim a kill. In addition to cannons, some Me-262 variants could launch R-4M rockets. These tiny but potent air-to-air rockets allowed a pilot to attack from outside the range of defensive machine guns. Just a volley of these rockets could scatter a bomber formation and send B-17s and B-24s tumbling earthward. The combination of blistering speed and heavy armament made the Me-262 a truly dangerous adversary, if it could get into the right position to attack. This potency on paper established the Me-262 as a game-changer. It wasn't only about intercepting bombers, it was also fast enough to outpace escorting fighters. In theory, the Me-262 could dash through bomber formations, unleash deadly volleys, and then climb out of reach before P-51s or Spitfires could react. With enough of these jets, the Luftwaffe could have potentially reversed the Allied air superiority that was strangling Germany's war effort. Building a revolutionary aircraft in a time of total war posed immense challenges. By the time the Me-262 was ready for mass production, Germany's industrial base was under siege. Allied strategic bombing raids targeted factories, rail yards, and supply lines. The dispersal of manufacturing to underground facilities and small workshops made consistent quality control pretty difficult. Moreover, the Jumbo 004 engines demanded metals that Germany could not easily access by 1944. Substitutions were made that compromised durability. Skilled labor was in short supply, replaced by forced laborers and hastily trained workers. The tolerance required for reliable jet engines was unforgiving, and even minor errors could lead to catastrophic failure. In addition, bureaucratic hurdles slowed production. Constant design changes, shifting priorities, and political meddling, from Hitler down through the ranks, further complicated matters. By the time the war ended, fewer than 1,500 Me-262s were produced in total, and only a fraction of those ever reached operational readiness at the front. One of the greatest tragedies of the Me-262's development was actually Hitler's misguided intervention. Initially conceived as a high-speed interceptor to tackle Allied bombers, the Me-262's potential role was clear: gain air superiority by shooting down enemy formations before they could drop their bombs. But Hitler, entranced by the idea of an unstoppable blitz bomber, insisted that the Me-262 should become a bomber itself, delivering vengeance against Allied cities and troop concentrations. The diversion delayed the aircraft's introduction as a fighter by several critical months. Time was something that Germany could ill afford, while engineers scrambled to adapt the Me-262 into a so-called Stormbird fighter bomber. Now, Allied bombers continued to exact a heavy toll on German industry and infrastructure. The bomber variant was less effective than hoped, and when the Me-262 finally entered fighter service in meaningful numbers, the worst tide had long since turned. Hitler's insistence also caused friction within the Luftwaffe's high command. Figures like Adolf Galland, a renowned fighter ace, argued vehemently that the jet's best use was as an interceptor, but his pleas fell largely on deaf ears. The disconnect between political leadership and frontline reality meant that the Me-262's golden window of opportunity had passed unexploited. When Allied pilots first encountered the Me-262 in combat, they were taken aback by its speed. The jet could surge past bomber formations almost at will. Chasing an Me-262 was futile. No piston-engine fighter could sustain such speeds. Initially, Allied intelligence struggled to understand the nature of the new threat. Pilots reported strange aircraft that looked and sounded unlike anything they had seen before. American bomber crews, who had grown accustomed to BF-109s and FW-190s, found the Me-262 a terrifying prospect. Its guns and rockets could rapidly dispatch even the toughest of four-engine bombers. But as frightening as the jet's capabilities were, its presence in the skies was always limited by reliability issues, scarce fuel, and a lack of trained pilots. The Allies quickly devised tactics to counter the Me-262. They targeted jets on the ground, bombing their airfields and catching them during takeoff or landing, when their slow speeds rendered them vulnerable. Escort fighters like the P-51 Mustang began prowling near known jet bases, ambushing the Me-262s as they tried to form up after takeoff, or as they returned low on fuel and ammunition. The Allies also learned to vary their bombing altitudes and to adjust their defensive formations. Adaptation, combined with the Me-262's small numbers, prevented the jet from reshaping the air war as Germany had hoped. Though it never lived up to its full potential, the Me-262 did have moments of brilliance. In some encounters, a single Me-262 pilot could blast through a formation and down multiple bombers before the escorts could react. Legendary Luftwaffe aces found that the jet allowed them to preserve their lives and continue fighting even as Germany's position crumbled. It gave them a fighting chance to survive missions that would have been suicidal in piston fighters by late 1944 and early 1945. Yet for every success story, there were a lot of setbacks. Lack of spare parts kept many jets grounded. Fuel shortages forced pilots to ration flight hours, limiting training opportunities. Mechanical breakdowns, engine fires, and landing accidents plagued the squadrons. The Me-262 often found itself unable to perform at the pace demanded by a war that was slipping through Germany's fingers. Operationally, the Me-262 once showed the world what was possible, but it arrived too late to alter strategic outcomes. By the time it was fielded in numbers that could be meaningful, Allied armies were already marching into the heart of Europe. No technology, however advanced, could reverse the reality on the ground. Had the Me-262 appeared in strength a year earlier, it may have significantly affected the Allies' bombing campaign. The timing of the arrival was critical. The Allies had perfected their system of bomber escort, timing, and strategic targeting. The Luftwaffe was already crippled by attrition and facing insurmountable odds. The jet was like a secret weapon revealed at the 11th hour, when only a miracle could save the regime. Now, numbers tell the story. Approximately 1,400 to 1,500 Me-262s were built, but many never left the ground for lack of engines or experienced pilots. The Allied air forces deployed tens of thousands of aircraft, hundreds of squadrons spread across a wide front. Against this overwhelming force, a few hundred jets, even revolutionary jets, could not single-handedly rewrite the script of a global conflict. By the time the Me-262 arrived, the Luftwaffe was fighting a defensive war in every sense. Fuel shortages meant training new pilots was curtailed. Veteran pilots, if they did survive, were worn down by relentless duty. Airfields were bombed regularly, which forced planes to operate from compromised runways or hastily prepared strips. The infrastructure needed to support advanced jets just simply didn't exist in the required forms and quantities. Moreover, Germany's radar and air defense network had been totally compromised. Communication lines were disrupted, and direction-finding equipment was often destroyed or unreliable. Even if the Me-262 could intercept Allied bombers, getting them into the right place at the right time became increasingly difficult. In strategic terms, the Me-262 was a tool that required a strong hand to wield, but the Luftwaffe's hand was weak and trembling by late 1944. The conditions for sustained jet operations, stable supply chains, secure bases, adequately trained ground crews, ready access to spare parts, all of that was all compromised. There was no fertile ground for the jet to blossom into a war-winning superweapon. It could only serve as a noble but doomed last stand. Now, the Allies were not passive observers of the new jet threat. Intelligence units pieced together scraps of information, concluding that this new enemy fighter must be engaged on the ground or during vulnerable phases of flight. As a result, jets found Allied fighters waiting overhead when they took off or returned to land. P-51's exceptional range and agility made it a perfect watchdog near German jet bases. Moreover, Allied strategists realized that massive bomber formations could still saturate German defenses. Even if a handful of jets took out a few bombers, hundreds more would deliver their payloads, and each sortie eroded the German ability to repair and rearm. Without sufficient numbers of jets operating simultaneously, the Me-262 couldn't hope to save Germany's crumbling infrastructure. And at the technological level, the Allies started planning their own jets. The British Gloucester Meteor was introduced about the same time as the Me-262, though initially it was deployed primarily against V-1 flying bombs. Now, the Americans were developing the Lockheed P-80 Shooting Star, which would be ready after the war's end. By the time the Me-262 could have made a difference, the Allies were already looking toward the jet age themselves. The surprise factor and capability gap that Germany initially enjoyed shrank as Allied engineers hurried to close the gap. Now, when the war ended, the victorious Allies scrambled to capture examples of the Me-262. American, British, and Soviet forces were keen to examine its airframe, engines, and systems. The jet represented a leap into a future that everyone now recognized would dominate the next era of warfare. Engineers dismantled captured Me-262s and learned valuable lessons about swept wings, engine placement, and maintenance challenges. In the U.S., some Me-262s were flown for evaluation at Wright Field. American engineers noted the aircraft's strengths and weaknesses. They considered how to integrate its concepts into their own jet fighters and bombers. Likewise, in the Soviet Union, German jet technology influenced the development of the MiG-9 and later the infamous MiG-15. The British examined the Me-262 in detail, comparing it to their Meteor and identifying how to improve performance and reliability in future designs. The Me-262 also influenced tactics and doctrine. Air forces worldwide began rewriting their playbooks to incorporate the reality of jet combat. Higher speeds demanded new formation flying techniques, better instrumentation, and improved pilot training focused on rapid decision-making at unprecedented velocities. Though the Me-262 was a war machine through and through, its impact did not remain confined to the military sphere. The development of turbojet engines and the associated research into aerodynamics helped lay the foundation for the post-war commercial aviation boom. Civilian aircraft would soon adopt turbofan and turbojet propulsion, enabling transatlantic flights and ushering in the jet age of global travel. Lessons learned from the Me-262's metallurgy and manufacturing techniques guided improvements in engine reliability and maintainability. Industries refined their ability to work with high-temperature alloys, and the drive for more efficient engine designs led to powerful yet reliable turbines suitable for passenger jets. In a few short decades after the Me-262 first took off, the skies would be filled with jetliners carrying business travelers, tourists, and cargo at speeds and altitudes that were unimaginable in the 1930s. The Me-262 encapsulates the desperate ambition of wartime Germany. It symbolizes what can happen when a society pours enormous resources into a technological gamble while the ground beneath its feet crumbles. As an engineering feat, it was extraordinary, a glimpse of a future unchained by the limitations of propellers. As a strategic asset, it was a missed opportunity. It arrived too late, produced in too few numbers, and employed under flawed leadership and deteriorating circumstances. In some ways, the Me-262 represents the fork in the road for the Luftwaffe. Had Germany devoted its attention and resources earlier to jet development? Had Hitler trusted his experts and had the industrial capacity been protected from Allied bombs? Well, the Me-262 might have changed the complexion of the air war. But history is not kind to what-ifs. Instead, the Me-262's tale stands as a testament to the necessity of aligning advanced technology with sound strategy, proper logistics, and timely deployment. Perhaps the greatest legacy of the Me-262 was the technical and engineering knowledge that it bequeathed to the world. Designers learned that jet propulsion changed everything, from how airframes were stressed at high speeds to the importance of materials able to withstand greater thermal loads. The Me-262's relatively crude engines taught engineers the necessity of reliable, high-quality turbine blades and compressors. The complexity of maintaining a jet fighter under wartime conditions taught valuable lessons in ground crew training, all took on new importance. The complexity of maintaining a jet fighter under wartime conditions taught valuable lessons in field logistics and maintenance. Fuel quality and availability, engine change intervals, and ground crew training all took on new importance. Future air forces would draw on these lessons to ensure that their jet fleets remain not only advanced, but also consistently airworthy and ready for action. From an aerodynamic standpoint, the Me-262 gave the world a blueprint for high-speed flight. Although not as swept as post-war jets, its slightly swept wings helped reduce drag and delay the onset of compressibility problems near transonic speeds. These findings pushed aerospace engineers to experiment with even greater wing sweep angles, ultimately leading to the familiar shapes of Cold War-era fighters and bombers. Now, over the decades, the Me-262 has captured the imagination of historians, aviation enthusiasts, and model builders. It appears in countless documentaries, museum exhibits, and air shows, sometimes in restored or replica form. Its sleek shape and eerie engine whine evoke a sense of otherworldly innovation. In many ways, the Me-262 became a potent symbol of what could have been. Some see it as a tragic missed opportunity, but others as a terrifying portent of what a prolonged war with more widespread jet use would have looked like. For American audiences in particular, the Me-262 underscores just how close the Allies came to facing a technologically superior adversary in the skies, and it highlighted the importance of timely intervention and production efficiency. The failure of the Me-262 to change Germany's fate is a reminder that technology alone does not win wars. Effective strategy, leadership, resource management, and industrial capacity are just as vital, if not more so. The aircraft's story demonstrates that no matter how advanced the weapon, if it's delayed too late and in insufficient numbers, its impact will be blunted. Moreover, the Me-262's legacy serves as a warning against political interference in military design. Hitler's meddling delayed the fighter variant just long enough to ensure that it couldn't stem the tide of Allied bombers. Had Germany's top aviators and engineers been given free rein to employ the jet as an interceptor from the start, its operational history might read quite differently. In a broader sense, the Me-262 reminds us that warfare accelerates technological change, sometimes at a breakneck pace. Yet that acceleration often comes at a terrible cost. The resources, lives, and energies expended to build, test, and field such a weapon weighed heavily on the moral balance sheet of history. The Me-262 was an artifact of a time when the world was consumed by conflict, and its very existence invites us to reflect on the paths not taken, the opportunities missed, and the horrors that drove men to create even more powerful instruments of destruction. It's impossible to tell the story of the jet age without mentioning the Messerschmitt Me-262. Even though it failed to alter the course of World War II, it did succeed in showing the world what the future of flight would look like. Within a decade after the war's end, jets became the standard in military aviation. Within 2 decades, commercial airliners ferried passengers across oceans at high altitude and high speed. The Me-262 stands at the cusp of old and new, representing the twilight of piston engine dominance and the dawn of jet power. Its lineage can be traced forward through every subsequent generation of fighters and bombers. Those who study aviation history find in the Me-262 a wellspring of insight about how leaps in technology come about and how they can be mismanaged, and how they ultimately influence the broader trajectory of human progress in the sky. The Messerschmitt Me-262 emerged as a beacon of possibility amidst the darkening landscape of total war. It introduced the world to the exhilarating potential of jet power and forced everyone to rethink what was possible in the skies. Yet, its promise could not overcome the crushing weight of reality. Late introduction, flawed leadership decisions, and insufficient resources sealed its fate. Today, the Me-262 is a legacy of lessons. It tells us that advanced technology alone is no guarantee of victory. It reminds us that timing, strategy, and industry have to align for innovation to matter. And it stands as a milestone, marking the moment when humanity stepped into the jet age. From that point on, the speed of flight would never again be constrained by the turn of a propeller, but rather by the imaginative power of engineers and the courage of those who dared to fly. And if you've enjoyed diving deep into stories like this one, hit that subscribe button now and join us for more untold tales of aviation wonders, groundbreaking technologies, and the remarkable journeys that shaped our skies.